So in today's lesson, we're going to talk about writing and solving proportions. And this is a little bit of an introduction to geometry. When we get into geometry next year, we'll talk a little bit more about proportions and different sizes and whatnot. But today we're just going to talk about just writing and solving proportions as compared to different size figures. So in geometry, if we have two objects or figures, we call them similar if they have the same shape but are not necessarily the same size. So for instance, if I drew two right triangles, these two triangles would be considered similar. They're not the same size, but they are the same shape. They're two different right triangles. So that would be similar. So anytime we have corresponding angles of similar figures, we call that congruent, and they have the same measure. So again, like this, if this, let's say this angle here was, what do we call it, 60 degrees. This one up here would be 30 degrees. The same thing here. This one right here would be 60 degrees. This angle up here would be 30 degrees. Okay, the same, as long as these two figures are the same shape, then the corresponding angles of similar figures are going to be the same, are going to be congruent. And so anytime we talk about something being congruent, we'll use a little sign looks like this. Now when we talk about trying to relate two different size figures, we call that a scale factor. A scale factor is the ratio of side length of a figure to the side length of a similar figure. So anytime you ever see, again, this is going back to using a little bit of those ratios, but if we saw a scale factor of 1 to 3, something like that is for every inch maybe of one figure, it'd be 3 inches on another figure. So that's a scale factor. So let's take a look at example 1 here. We need to find the measure of angle Q and the measure of angle W. So this one's fairly simple. Again, we have two similar figures. We know that PQRS is similar to WXYZ. So the two figures are similar, and we need to find the measure of angle Q. Well, measure of angle Q is up here in this spot here. Well, if you look at the two similar figures, they correspond. Again, their angles, anytime we have similar figures, their corresponding angles are congruent. So in this case, Q is going to be equal to 80 degrees. And then we need to find the measure of W. And we see W over here would correspond to P, so we know that W is 120 degrees. And if we look at example 1, part B, it says find the scale factor of PQRS to WXYZ. Now, here we just need to find the difference between the two, the ratio of the different two. So we look at two corresponding sides here. We have PS is 3 and WZ is 2. Well, there can be your scale factor right there. It's 3 to 2. So our scale factor would just be 3 to 2. You could write it as 3 over 2. Again, this is like a ratio, or 3 to 2, however you wanted to write it. But our scale factor for these two figures would be 3 to 2. Now we need to look at example 1, part C. It says use a scale factor to find QR and ZY. So again, we already have our scale factor as 3 to 2. So we'll set this problem up 3 to 2. And we need to let's find QR. So we have QR is going to be set up with a 3. So we're going to say is equal to A over, and then the 2 is set up with the 5. So make sure you always set things up. The 2 is lined up with a smaller figure, which means the 5 is going to be set up with a smaller figure. Once we have this now, we'll go ahead and just cross multiply and solve our ratio. So we get 2 times A would give us 2A equals 3 times 5 is 15, and we'd get A equals, when we divide that, 7.5. So A in this figure would be 7.5. Now if we need to find ZY, we're going to do the exact same thing. So I'm going to erase this real quick. And we're just going to set the proportion up the exact same way. Again, our scale factor was 3 to 2. So we'll go 3 to 2. And this time we have the SR we already know is 6. So we'll set the 6 there and put the ZY as B. So now we're just going to cross multiply again. So 2 times 6 is 12 equals 3B. We divide there and we get B equals 4. So that's how you would find both A and B in those figures. So now that we've talked a little bit about scale factor and we've talked a little bit about writing and solving some of these proportions, sometimes in drawing we can do the same thing. So if you guys remember seeing a building or if a house, you have the house but you have its blueprint, and that blueprint is a drawing that we can talk about. So a scale drawing is what it is. A scale drawing is a drawing that reduces or enlarges the dimensions of an object by a constant factor. So if you see a scale drawing of a house, it might be a smaller version of a bigger house, but it's a smaller version so you can see things, maybe on paper. And then we talk about scale. Scale is a ratio showing the relationship between a scale drawing or a model and the actual object. So when we talk about drawing something to scale, so in geometry we'll work on a couple of projects about drawing something to scale, or you'll hear, anytime there's a big building project, you'll talk about drawing something to scale. That's what it means. It's just the ratio of is the ratio showing the relationship between a scale drawing or a model and the actual object. So take a look at example 2 here. It says a desk is designed to have 3 drawers on the right side. In the scale design drawing, the width of the drawer is 4 centimeters. If the scale of the drawing is 1 centimeter to 7 centimeters, how wide will the actual desk drawer be? So we talk about 1 centimeter for every 7 centimeters. And on the drawing, the drawer is actually 4 centimeters in the drawing. So we need to figure out how actual wide the drawer will be. So we're going to put X here. And again, we're just setting up a proportion just like we did in the previous lessons, and we're going to cross multiply. So then 1 times X is going to give us X, and 7 times 4 is going to give us 28. And so we'd get 28 centimeters would be the actual desk drawer would be 28 centimeters in the actual drawing.